Hello again, everyone. So in the last video, we made a skeleton LSM, and that skeleton LSM printed out the names of every user space executable right before it was about to be exec'd. I didn't go into too many details about how that happens. So in this video, I'm going to go into more details about how it actually occurs. So first things first, let's take a look at a function that prints out the name here. So as we saw in the last video, we've got this Linux BPRM, bin PRM structure, and we're using it to print out the name as per the comment in elixirbootland.com. But the thing is, how do we arrive at this function? So we're going to take it on faith that this define... Oh, we found a bug here. We shouldn't be Yamma. We are my test. Okay, no worries about that. We're going to take it on faith that this is going to run the initialization such that my test init is going to execute, and this my test init adds my test hooks to a list of LSM security hooks. So what is that LSM security hook stuff? Let's see if I can get my my page a little bit nicer to look at here. There we go. So in security.c, when you call this security add hooks, it simply adds your array of LSM hooks, and it goes through a for loop here, and it simply adds your hooks onto whatever list there is. So what lists are there? Well, there's a whole bunch of lists here. And those lists are found back in this LSM security hook file. So here's all the lists that we have. Security hooks. So they are just an HList head, so it's just a linked list. And what we are doing is we're adding our myTest BPRM check security, our function, onto the checks security list. So what does that mean? Well, every time this list is looked at, it's going to run our function. But when is this list looked at? Oh, that's a little bit tricky. Okay, we're going to have to go a little bit deeper into the Linux source code here. So a utility I like to use is called Cscope. And in order to use Cscope, what you want to do is first build up a list of files that you want Cscope to look through. So you can do that with the find utility. And we're looking for any C or H file. And we're going to redirect that into a file called cscope.files. Cscope files. And then we get Cscope to index those files by using cscope-b-q-k. And it takes a few moments to process through things, especially when our CPU is being abused by the OBS screen recording utility. Cscope is a very, very old utility, so it's single-threaded as well. You can find Cscope either through your most distributions have it, so you can, if you're on Ubuntu, you can apt-get install it, or on Fedora you can DNF install it. But it's still hosted on SourceForge, and the last update was, nearly 7 years ago. As you can see, it's nearly 20 years old now. Some important things about Cscope that you'll want to do is edit your bash RC such that you have this Cscope editor set up, Cscope line flag and Cscope line after flag set up. And if you're using Sublime, you have to actually edit the source code of Cscope to make it work with Sublime. At least make it work with Sublime the way that I want it to run. We're not going to worry about that in today's video, but if you want me to make a video about editing the Cscope source file in order to make it work with Sublime Text well, I can do that. Just post in the comments below. It'll be a really quick video. Anyways, we've fully indexed our files here. So if we give it a cscope-d, it'll pop us up into this ncurses editor. And we're looking for that BPRM check security. So let's take a look for that. So we can see that it's in LSM hooks. It's used in the Tomoyo, and that's another LSM. And it's also used in security.c. So let's open that security.c. And we can see that the hooks are called inside of this security BPRM check. So what's this call int hook? Take a look at that in Bootlin. And it's a macro, and it just goes through the linked list, and it calls all the hooks. So where is this security BPRM check called from? Search inside of Bootlin to find it, and we see it used in a few places here, but the one that interests us the most is the exec.c file. So if we jump into that, we can see it being called here on line 1644, and it's called from the search binary handler. So where is search binary handler called from? Well, that's where the export is, but that's not what we want. All right, it's called from exec bin PRM, but where is that called from? So we keep going deeper here. And that is called from this __ do exec ve file. So this is the this is where a lot of the work from the exec ve system call is. So what it's going through here is it's basically setting up the process to be run. And if everything checks out, it's going to run the process here. Another thing that you should be interested in is the prepare bin PRM. And you should be interested in that because in the pipeline of this prepare bin PRM, this security BPRM set creds is called. And that will boil down to this call here, the security BPRM set creds. So if you're looking at a bunch of LSMs, you will often see this bin PRM set creds hook being used rather than the security check being used. And that happens because we have a lot of the information that we need to make a decision about whether we want to allow an executable to be executed or not at the prepare bin PRM stage. And if we stop the execution here, we skip a lot of these string copies. But what exec bin PRM has that the prepare bin PRM doesn't have is it doesn't have these strings copied into it. And these strings specifically are the arguments that are being used for the argv, argc, and the environment variables that are passed into the C program as it's being executed. So if you want to get those, you have to use the security BPRM check rather than the set creds security check. Anyways, let's just go up a little bit farther. And we can see that the __ do execve file call is being called by the do execve file call. And that is being called from where are we here? There. Anyways, we're jumping a little bit too deep into the rabbit hole here. Suffice to say, it's called when the execve system call is run. And it's a list of it's from a lot of these different execve types that are being run here. So execve goes into do execve, which goes into the common one. The common one goes into the __ do execve _file. So that's how it's being called. So what are some of the other LSM hooks that you can look at? Well, back inside of this LSM _ hooks.h file, you've got a long list of all these different hooks. And this file also contains documentation on what these hooks do. So check security. This hook mediates the point when a search for a binary handler will begin. It allows a check the BPR, well, obviously some editing for the grammar can be done here. It allows a check the BPRM security value, which is set in the preceding set creds call. The primary difference between set creds is that the argv list and the np list are reliably available in the BPRM structure. This hook may be called multiple times during a single execve, and in each pass, set creds is called first. So some of the other things are some of the other interesting ones are obviously that set creds one, but There's also stuff that you can do based on when your inodes are being looked at. So when you're opening up a new file, so when you're doing things like making a node, when you're doing a symlink, when you're creating a node, so a file is a node, those things can be looked at. When the permissions are being looked at for a file, when you're mapping a file, when you're opening a file, things like that. All of this can be looked at here. So let's make another hook for this file open one. So what we're going to do is let's break this out so that we've got two things here. And we need to have a static int, and we're going to call it my test file open. And the struct we have is a pointer to a file. And we're going to do a simple print k to the error level. And we're going to say hello from and what's some interesting stuff that we can get from the file structure. So let's go back into this area and look up file. Back into Bootlin and look up file. And in linuxfs.h, this gives us the file structure. So what are the things that we want in here? Well, the path might be interesting. Is there something really easy that we can look at? Really simple. No, the path is the most simple thing that we can look at here. So let's dive into the path. And what are some things in the path that we can get? Well, we've got a VS mount and a D entry. So if we look into a D entry, we've got a Q string here, and it's got the D name. Is there anything really simple here? No? Okay, what's a Q string? A Q string is a union of a hash length or this structure and a name. So maybe we can grab that name from the Q string. So let's print out a string, and what we're going to do is from file to, where was our file? File to fpath. And this is not a pointer to oops. File to the fpath. Gonna have to reopen the path stuff here. To a dentry, D entry, into a D name, into this name. Now we're not doing any error checking here, and I might have got my referencing and dereferencing a little bit mixed up, but the compiler will tell me if I've screwed up. Print K. No return statement. And we haven't actually added it to our LSM hooks. So let's finish this off. And we want to add an LSM hook for the file open. Okay, let's try it again. Now, when we run this, I suspect that our dmessage log is going to be absolutely flooded here. But let's give it a try. So we can see that we're being called here quite a lot. So that's interesting. So let's do a cat. Let's first touch a file. We'll call it file.txt. And what happens here? It opens up a bunch of shared libraries. And then it opens this file.txt. So what happens when we cat file.txt? And again, we see that stuff happening here. So, you know, there's quite a lot of information here, but it is printing out when we're opening this file.txt. Interesting. Anyways, I think that's enough for today. Thank you very much for watching.